This is problem number 5 on the sample test problems for test number 1. Maria plans to deposit $1,000 into an investment account. 3 possible accounts are described below. For each account, write a formula for the amount of money Maria will have after T years. Also state the effective annual yield for each account. Part A, we pay interest at a nominal rate of 7.5%, compounded 4 times a year, quarterly. Okay, when we see this kind of compounding, we use the formula A equals P1 plus R over N to the NT. In this case, the principal, we'll just leave it as a P. We don't know what it is. 1 plus R is the interest rate. As a decimal, it's 0.075. Divided by N. N is the number of times you compound interest each year. That's 4 because we're doing it 4 times a year or quarterly. Raised to the NT. 4 times T. So that's our formula. If you want, you could type in the number in the parentheses to get a single decimal, but this is our answer. And then it says state the effective annual yield. So the effective annual yield for this one is just a little formula. It's this. So here's the effective interest rate. It's 1 plus R over N to the N, subtract 1. So in our case, 1 plus 0.075 divided by 4, raised to the 4, subtract 1. We'll type this into the calculator. So we're doing parentheses, 1 plus 0.075 divided by 4, close parentheses, raised to the 4th. And then subtract off the 1 from that number. And we get our answer is a little bit over 7.7%. Okay, part B, we pay interest at a nominal rate of 7.3% compounded continuously. Different formula for this one. This is PERT. A equals PE to the RT. Principal is just P. Interest rate is 0.073. T is T. So that's our formula. And if we want the effective rate, it's a little bit different. The formula for the effective rate is E to the R, subtract 1. So E to the 0.073, subtract 1, and we'll type this into the calculator. And then subtract 1 from that, and we get about 7.57. C, the amount of money in your account will double every 10 years. This one requires some more work. There is a kind of a straight doubling formula you're welcome to use. I'll put it here, but it's not necessarily something you need to use. So here's the straight doubling formula. You take the principal, you multiply it by 2 because we are doubling, and then you take T and you divide it by the number of years it takes to double. P times 2 to the 10 over T. That answer is fine. But it's not really a formula we use very much, so I'll give you a different version of things. So instead, how about we do this, A equals P times 1 plus R to the T. We know that the money is supposed to double in 10 years. What we don't know is the interest rate. So it feels like if we start with P, we wait 10 years, that the money should double. Doubling from P means 2P. And then divide both sides by P. We're trying to solve this equation for R. It's very tempting to use logs, but you use logs when the variable is up in the power. In this case, that's not true. So what we really want to do is raise both sides to the 1/10, because that will cancel with the 10th power on the right. So what we end up with is 2 to the 1/10 equals 1 plus R. So the interest rate here is, well, Well, we'll pause on the interest rate. We'll just type in this 2 to the 1/10 onto the calculator. So we go 2 raised to the parentheses 1/10. And we get 1.07 and change. So this is roughly 1.072. And so then the formula that we're after is just this guy. A equals the principal. 1 plus R we've just discovered is around 1.072. And that's raised to the t. And so if I'm after my interest rate, well, I think I can just grab it from this formula or from this equation. R is then 1.072 minus the 1. So the effective rate there is about 7.2%.